Let's talk about the quotient rule. The quotient rule is another differentiation formula that's really important. So I'm going to put a couple stars here because it's a rule that sometimes trips students up, and I wanted to draw special attention to it. So you're very mindful of how to differentiate a quotient of two functions. So a quotient of two functions basically mean we're dividing two functions, and we want to take the derivative of it. So let me put the differentiation operator out in front like this. And the quotient rule works like this. We're going to take the derivative of the first function, so the top function, so that'll be f prime of x. We're going to multiply by the second function, g of x, and then we're going to subtract the derivative of the second function, g prime of x, times the first function, f of x. And this is all over the denominator. And the denominator is just the bottom function squared. Okay, so this rule is definitely one that we need to know because we use it all the time in calculus. So I'm going to highlight it like so. If you look at the numerator of the quotient rule, it almost looks like the product rule, except for one pretty significant difference. There's a minus sign here. So let me highlight that minus sign just so that you don't forget it. All right. So why don't we look at example 8 together, and we can use the quotient rule to differentiate this j of x function. So the numerator is 4x cubed. So why don't we write it like this? We'll say f is equal to 4x cubed. That means the derivative of f prime, is going to be what? Well, we can use the constant multiple rule. So the 4 is going to stay there. We're going to multiply by the derivative of x cubed. That's going to be times 3x squared. And when I simplify that, that's going to give me 12x squared. So that's the f part. Let's take the derivative of the g part, the bottom function. So the bottom function is going to be g of x equal to 5x plus 2. All right. So when I take the derivative g prime of x, that derivative is going to be, when I look at the first, I have to actually use the sum rule here. The first function is just 5x plus the second function is the constant function 2. So when I take the derivative of 5x, it's really a constant multiple rule. The 5 stays there, and the derivative of x is just 1. Then I add the result of the derivative of the second function, which is 2. The derivative of 2 is 0. And when I simplify this, this just gives me 5. Okay? So now I want to apply the quotient rule to my j of x. So when I go to write down the derivative j prime of x, how is that going to look? Well, I know it's going to be a fraction, so I'm going to put a little long line here, a long crooked line. The derivative f prime is just 12x squared. We are going to keep the g function, so I'm going to put quantity 5x plus 2. We know that we want to subtract what we get when we take the derivative of the second function, which was 5, times the top function, which is 4x cubed, like this. And this should all be divided by the bottom function squared. So that'll be 5x plus 2 quantity squared, like this. Okay, why don't we simplify our derivative a little bit? and, write it all in one color. So for the numerator, actually, let me say one thing first. Uh, I want just to quickly mention that I cannot cancel this 5x plus 2 with this 5x plus 2 here. Sometimes students try to do that, but that's illegal because of this subtraction sign here. So if you're able to factor out a 5x plus 2, then you could cancel. But because you have this difference over here, you don't have 5x plus 2 in both terms. So you can't just cancel like that. That's an algebraic error. So instead, we need to distribute. So let's distribute the numerator. 12x squared times 5x is going to be 60x cubed. And then 12x squared plus 2 is going to give me 24x squared. And then when I simplify the second term, that's going to be negative 5 times 4. That's going to give me negative 20x cubed. For the denominator, I could just multiply that out. 5x squared is just 25x squared. I know that the middle term is going to be the product of the two terms times 2. So 5x times 2 is 10x times 2 is 20x. And then the last term squared is going to be plus 4. Okay. I can see that I have like terms in the numerator over here. So when I combine those like terms, I'm going to get a final answer of 40x cubed plus 24x squared divided by 25x squared plus 20x plus 4. All right, everyone. We'll work on lots of examples in class together. Take care.